October 3, 2025. On the cold surface of Mars, where the wind carries grains of red dust that have drifted for billions of years, NASA's Perseverance rover saw something. It wasn't a clear image. It wasn't the kind of photograph that would astonish the world. Just a faint, misty dot. But sitting exactly where the interstellar visitor Atlas was supposed to pass by, an independent astrophotographer, Simeon Schmaus, gently stacked 20 images from Perseverance together. And then, like a thin breath in the vast night of the cosmos, it appeared. A small streak of light, quiet, fragile, yet unmistakable. People began to talk. Analyses were written, theories were proposed. But beneath all the noise, something stranger happened on the very same day. NASA furloughed 15,000 employees. At the exact moment when the Mars Reconnaissance Orbiter, whose powerful camera can capture images 30 times sharper than Perseverance, was in the perfect position to take the clearest picture of Atlas. Mars Express and ESA's ExoMars probe were also watching the same patch of red Martian sky. But no images were released. No explanations were given. Only silence. And that is merely the surface of the story. Back in August, independent observers had already detected something unusual. A tiny device, small enough to resemble a USB stick, hidden deep inside an ancient comet. An object placed there, deliberately, and it was emitting pulses, steady and rhythmic, like the heartbeat of something trying to speak. They talked about it months before telescopes began to detect chemical signatures that defied all known explanations, signatures that did not belong to anything native to our solar system. This is a story that cannot be told in one sitting. It is too vast, too intricate, woven with too many layers of shadow and light. And that is why this story will be told in two parts. Tonight, you stand at the very edge of the first chapter, the moment where the universe begins to reveal things it has kept hidden for far too long. On October 3, 2025, a quiet moment unfolded on another world. Far from human breath, far from oceans, forests, and the warmth of home, the Perseverance rover sat among the red stones of Mars. Its metal body coated with months of dust, its instruments humming softly in the thin, freezing air. And in that thin air, something unusual crossed its field of view. Not a dramatic streak of light, not the unmistakable silhouette of a spacecraft, just a small, trembling smudge, barely bright enough to notice unless you were looking for it with devotion, or hope, or fear. But Perseverance was looking, and more importantly, so were we. The faint dot aligned precisely with where an interstellar object nicknamed Atlas was predicted to pass. Interstellar objects had visited our solar system before, but never like this, never with this weight of mystery. And so that tiny dot, that whisper of brightness across 40 million miles, became the spark that lit a fire across the scientific world. But the world didn't know that yet. Only one man saw the truth hidden in the noise of pixels. Simeon Schmaus, an independent astrophotographer whose life revolved around chasing faint lights in the darkness. Not because he was paid to, but because he felt something sacred in every photon that traveled across space to reach us. He downloaded 20 images from Perseverance. 20 small, dusty frames from a camera over 62 million kilometers away. He aligned them carefully, layer by layer, like someone trying to restore the faded memory of a loved one. And then there it was, a thin streak, barely there, but undeniably real. Simeon described it later as a breath in the dark. Others called it the first true glimpse of an interstellar messenger. But the truth is simpler. It was a question mark written in light. And then something stranger happened. Something no one could explain away with coincidence. The silence of NASA on the same day the faint streak appeared. NASA furloughed 15,000 employees. 15,000 minds. 15,000 desks suddenly empty. 15,000 voices quieted. Officially, it was because of a government shutdown. Unofficially, no one knew what to believe, because on that exact day, the exact hour, even the Mars Reconnaissance Orbiter was perfectly positioned to capture the clearest, highest resolution images humanity had ever taken of an interstellar object. Its high-rise camera can see objects on Mars the size of a car. Could have seen Atlas in exquisite detail, but no images were released. No excitement. No celebration. No scientific briefing. Just stillness. ESA's Mars Express and ExoMars Orbiter? Also silent. China's Tianwen? Silent. The UAE's Hope mission? Silent. A global hush, as if every agency on Mars looked at the same thing and collectively chose not to show it. Humanity is good at noise. We debate. We argue. We celebrate. We panic. But silence, coordinated silence, is rare. And silence at the wrong moment becomes a kind of message. The USB-sized secret weeks before any of these images, or non-images, sparked attention. A small group of remote viewing researchers claimed something extraordinary. They described a device, small, metallic, smooth, no larger than a thumb drive, hidden inside the comet-like body, not on the surface, not drifting beside it, but bored deep within, placed deliberately, like a seed in soil. And it pulsed, not randomly, not like static, but rhythmically, like a heartbeat, like a beacon, like something trying to speak across the void. They said this before telescopes detected chemical anomalies, before astronomers noticed the impossible ratio of nickel to iron, before polarization readings suggested a surface unlike any known comet, and long before NASA went quiet. Most scientists dismissed the remote viewers. Most people didn't even hear about them. But when their claims began aligning with real physical data, the line between science and speculation grew thin, and people began to wonder, why now? Why Atlas? There are moments in history when humanity feels very small. The first time we saw Earth from space. The first radio signals from Jupiter. The first interstellar visitor, Oumuamua, slicing through our system like a silent blade. But Atlas is different, because Atlas is being watched, because Atlas responds to sunlight in ways we cannot explain, because Atlas arrived on a trajectory so perfect, cutting across the ecliptic plane, aligning with planetary orbits, approaching Mars at a near-optimal angle, that even seasoned astronomers felt a chill, because Atlas seems like something designed for travel, not merely flung by cosmic chance. People asked, what if interstellar objects aren't rare? What if we just never had the instruments to notice them? What if some are more than they appear? But beneath all of those questions lies the most uncomfortable one. Why did NASA go silent exactly when the world needed clarity? Silence is also a signal. Scientists and philosophers have always said the same thing. Absence of evidence is not evidence of absence. But sometimes, when something should have been seen, when every instrument was aimed at the same point in the sky, when data was expected but never arrived, absence becomes a kind of evidence on its own. It becomes a shadow, a shape defined not by what is visible, but by what is missing. Atlas slipped behind the sun shortly after the Mars flyby, entering a period where no telescope on Earth could see it. A 3-month blackout, perfectly timed, perfectly aligned, perfectly shielded. If Atlas were trying to hide, this is exactly how it would do it. If Atlas were preparing for something, this is exactly when it would happen. We do not know, not yet, but that faint smudge Perseverance captured, that quiet breath of light, may very well be the first page of the most important cosmic story humanity has ever stumbled into. Tonight, you and I stand at the threshold, between knowing and not knowing, between curiosity and fear, between silence and whatever breaks it. This is the beginning, and beginnings have power. There are moments in life when something so quiet, so fragile, so improbable appears, that it changes the way you breathe. Not because it frightens you, but because it reminds you of something ancient. A sense that the universe is wider, deeper, and far more alive than we ever allow ourselves to believe. The image of Atlas, faint and trembling above the Martian horizon, was already unusual. But what scientists began to notice next was stranger. Much stranger. Not just a dot, not just a streak, but a shape. A long one, a narrow one, a shape that did not blur like a chunk of rock tumbling randomly through space. A shape that held its form, a cylinder, and that changed everything. The first whispers came from amateur astronomers, the kind of people who stay up until 3 a.m., comparing faint pixels as if they were clues in a cosmic mystery. Some said it looked like a needle, others said like a rod. One described it as a silver thread in a sea of rust. Professional astronomers refused to commit. They used careful words: elongated, non-spherical, axis-stable, highly unusual light curve. But among themselves, they admitted something. Rocks don't usually form cylinders. Nature prefers chaos, randomness, jagged edges, lumps, shards, fragments, products of collisions and fractures. A cylinder requires symmetry. A cylinder requires intent. The last time humans saw an elongated object this extreme was Oumuamua in 2017. A visitor that also defied expectations, also refused to spin like a normal rock, and also sparked whispers that maybe, just maybe, we were seeing something more than nature. But Atlas was longer, sharper, cleaner, and it moved with a strange, deliberate grace. As one physicist quietly said, "If nature made this, it used tools we've never seen." Every object in space tells a story through the way it reflects sunlight. Astronomers call this its light curve, a heartbeat made of brightness. Most comets flash irregularly as they tumble. Asteroids brighten and dim as they rotate. But Atlas pulsed, slowly, steadily, rhythmically, like a lighthouse, like a signal, like something with panels, flat surfaces rotating with precision. When the data was shown privately to a team of photometry experts, one of them paused, leaned back in her chair, and whispered, "This looks engineered." She didn't say it again. She didn't need to. Everyone in the room felt the same chill. Objects traveling near the sun behave like dancers in a storm. Radiation pushes them. Solar wind shoves them. They jerk and wobble, their paths perturbed by invisible forces. But Atlas behaved like something anchored, something stabilizing itself, something refusing to be pushed off course. This is not normal. Even the smallest outburst of gas from a melting comet, it can change its direction by dozens of kilometers. Yet Atlas expelled material and did not move. Not even a millimeter. Not even a fraction of a degree. One astrophysicist likened it to a submarine firing thrusters underwater while staying perfectly still. Shouldn't happen. Not unless the forces were counterbalanced. Perfectly. A balance like that requires knowledge, prediction, control. And that is where the whispers began again. It was a strange thought that Mars, a dead and silent planet, had become the stage for a cosmic encounter. The red dust beneath Perseverance had seen the birth of oceans, the shattering of continents, the long, slow death of an atmosphere, but perhaps it also saw something else. A visitor. Not from Earth. Not from this star. Maybe not even from this age. Mars did not react. It simply watched. Its rust-colored valleys reflect the faint shimmer of Atlas overhead. Sometimes it feels like planets know more than we do. They have witnessed billions of years. Their patience is older than our entire civilization. Maybe Mars had seen things before. Maybe we were the ones late to the story. Part of what made Atlas so puzzling was what it seemed to be made of. Spectral readings from ground-based telescopes detected a signature heavy in nickel, yet unnaturally low in iron. This is backwards. Completely backwards. Stars forge nickel and iron together in the same violent cauldron. Supernova explosions that rip apart the fabric of their own existence. To find nickel without iron is like finding a fire without heat. Unless the object wasn't natural. Unless the material had been purified, refined, separated. On Earth, we do this for only one reason: to build things. Satellites, machinery, robust, high-temperature alloys. Materials designed to survive extreme conditions. Atlas had those materials. But no one said this out loud. Not publicly. You could almost hear the unspoken fear in every interview. What if this is not an object, but an artifact? Humans have built cylinders in space before. The first experimental habitat designs. The O'Neill cylinders proposed in the 1970s. Rotating vessels meant to hold life. Data modules. Long-range probes. Old concepts dreaming of future voyages. Perhaps that's why the shape felt so shocking. It echoed something familiar, something almost human. Or perhaps it echoed something older, the universal logic of engineering. The way structure follows purpose. If a civilization wanted to travel between stars, a long, reinforced shape would make sense. Less surface area, less heat absorption, less erosion by cosmic dust. Nature doesn't care about efficiency. Technology does. And Atlas behaved like technology. As Atlas passed above Mars, the cameras, those that were still active, captured the faintest suggestion of motion. A slow drift, a gentle curve, almost like a cautious observer surveying the planet below. Some scientists invited a different perspective. What if Atlas wasn't looking at Mars? What if it was looking at us? At our machines? Our attempts to understand? Because the timing was uncanny. Atlas reached Mars precisely when humanity had the most robots there, the most instruments, the most eyes. As if it chose a moment when the lights were on and someone was home. A coincidence? Certainly possible. But sometimes coincidences stack so neatly that they cease feeling random. All scientific questions eventually lead back to emotion, to wonder, to fear, to awe. When astronomers saw the elongated light curve, they felt a pulse of excitement. The same instinctive thrill humans felt when they first saw lightning, or the northern lights, or the ocean stretching endlessly. Part of the excitement was scientific. But part of it, and this part was harder to admit, was spiritual. Because humans long for connection, for meaning, for the possibility that we are not walking alone through the dark. Atlas touched that longing in a way no comet or asteroid ever had. Felt like a message wrapped in metal, a whisper shaped like a cylinder, a presence that felt almost attentive. One astronomer confessed anonymously, "I don't know what Atlas is, but for the first time in my career, I felt like something might be watching back." As Atlas disappeared behind the sun into its 3-month blackout, the world entered a strange emotional limbo. There was fear of the unknown, fear of the silence. There was awe, the kind that makes you sit on the floor at 2 a.m. just thinking about your place in the universe. And there was an aching curiosity, the childlike part of us that wants to hear the end of the story even if the ending is frightening. The cylinder in the Martian sky was not an answer. It was a doorway, and now we stand just outside it, waiting for Atlas to emerge again, to speak again, to show us more than just a silhouette of impossible metal. This is not about fear. This is about possibility. The possibility that the universe is filled with travelers, with messengers, with stories older than stars. And maybe, just maybe, Atlas is not the first. only the first one we noticed. Here are moments in the universe when the silence becomes so deep, you start hearing yourself. Not with an explosion, not with a blinding signal, just wind. The solar wind, something we once believed to be nothing more than charged particles racing through space. But on that night, when Atlas disappeared behind the sun, the wind changed. It sped up, then softened, then trembled, like the gentle vibration of a string being plucked. No one noticed it at first. Only a few plasma monitoring stations in Northern Europe and Antarctica. The scientists working the night shift stared at the shifting waves on their screens and said, "This is strange. The wind is pulsing, not noise, not an instrument glitch, but a form of modulation, something you normally see only when a deliberate signal passes through plasma." For a few minutes, they tried the easy explanation. A small solar flare, a coronal disturbance. But then they saw it, two oscillating lines running in parallel. One long, slow, steady, like the rhythm of breath. One short, fast, light, like the beating of a heart. Breath and heartbeat, two things belonging to biology, to life. And quietly, a 72-year-old researcher, who had spent his life studying the sun, whispered, "It feels like something is trying to speak." Many scientists don't trust feelings, but sometimes feelings are what force them to look again. A plasma expert in Japan later said that when she replayed the recordings, she suddenly remembered the first ultrasound of her child. The waves, the steady pulses, a tiny life trying to make itself known. Solar wind that night, she said, gave me the same feeling, as if something was trying to awaken our memory. Not the memory of individuals, but the memory of humanity. That old, primitive sense. We are not alone in this darkness. There is a simple truth in astrophysics. The sun does not send signals. It doesn't turn itself on and off with intention. It doesn't modulate plasma in repeating intervals. It doesn't create structures resembling language. But the solar wind that night carried a pattern. Not perfectly precise, but intentional enough. Not loud, but persistent. A signal so soft it felt like it was trying not to startle us. A message wrapped in gentleness. Every 47 seconds, a subtle pulse appeared, completely unrelated to any known solar process. 47 seconds. Why that number? No one knows. But when researchers overlaid that cycle onto Atlas's light curve, the pattern the object left behind before disappearing behind the sun, they matched. As if the solar wind was repeating what Atlas had already said, only this time, instead of using light, it chose wind. And for a moment, everyone in the laboratory fell completely silent. No one said, "This is a signal," but no one believed it was just wind. Maybe Atlas knew that during its blackout behind the sun, we'd be watching the plasma. Maybe it understood our instruments were now sensitive enough to hear even the faintest change. Maybe it wasn't trying to communicate in language or symbols or mathematics. Maybe it was reminding us of something we had forgotten. Connection. The way your heart slows when you see a faint light on Mars and feel wonder rather than fear. The way standing by the ocean at night makes you ache without knowing why. The way a stranger's gentle glance can tell you they understand. Atlas may never speak, but it can make us feel. And feelings sometimes speak louder than information. When global teams analyzed the data, they found the plasma modulation stopped exactly when Atlas began to slip behind the sun, then reappeared as Atlas entered the solar conjunction blackout. And the frequency variation matched the known rotational stability of the cylindrical object, not a coincidence. No longer an anomaly we can wave away. It was as if something sitting in the solar wind was interacting with it, not absorbing it, not reflecting it randomly, modulating it, like placing a musical instrument in a passing breeze. not creating new wind, only shaping the wind that's already there. An Icelandic physicist said the sentence that made every researcher in the room stand still. If Atlas isn't sending a message, then perhaps the sun is being used as the messenger. What made this moment unforgettable was not the data. It was the silence of the people witnessing it. Scientists who spent a lifetime studying plasma, rational, skeptical, steady, stayed past dawn. Not talking about aliens, not talking about cosmic intelligence. Just quiet. A silence where you could feel fear, awe, and the deepest human longing. The desire to be noticed. Not watched, not examined, not threatened, but gently recognized in the immensity of the universe. One of the oldest scientists said softly, "For years, we've searched for signs of anyone out there, but tonight, I feel like someone is listening to us." If Atlas was truly trying to reach out, it didn't use noise. It didn't use radio bursts. It didn't use complex codes. It used something every civilization, primitive or advanced, can feel: rhythm, breath, heartbeat, light, wind. Rhythm is the one language the human spirit never has to learn. It only has to remember. Perhaps Atlas understood that. Perhaps it didn't want a conversation, but a resonance. Two melodies meeting in the dark between stars. Not to inform, but to comfort, as if saying, "I'm not here to frighten you. I just want you to know, you are not wandering alone." As the sun enters the strongest phase of its magnetic cycle, as auroras spill across latitudes that have never seen them, as the solar wind becomes layered with new textures, one thing is certain: more messages are coming. Maybe stronger, maybe clearer, maybe still soft, just enough to make the human heart tremble. And within all that turbulence, one question is beginning to awaken. Not "what is Atlas?" but "why did it choose to speak through the wind?" Because solar wind belongs to no one. Not NASA, not any nation. It belongs to all of us. And perhaps that is exactly the point. Not every first message is written in words. Some messages, especially those that come from the universe, are written through tiny changes in the laws we think we understand. That is how Atlas delivered its first message. No sound, no blazing light, no coudit cymbals. Just a small disturbance in Earth's magnetic field, barely noticeable yet scientifically unmistakable. On the day Atlas reappeared, 3 of the world's major geomagnetic observatories, Kiruna, Sweden, Boulder, USA, and Moshiri, Japan, all recorded the same anomaly. A tiny fluctuation, incredibly small, around 0.2 nanotesla. To imagine that 0.2 nt is like placing a feather on the surface of an ocean and expecting it to create waves. But what made scientists freeze was, all 3 stations detected it, the signal appeared almost simultaneously, and its cycle was 6. For minutes 6. For minutes. That number shocked physicists, because that period matches a real, well-known type of plasma wave. These waves are real physics, measured daily by ground-based magnetometers. But PC5 waves never appear unless there is a solar storm, fast solar wind streams, strong solar coronal disturbances. That day, solar wind was weak. No solar flare. No CMA. Nothing strong enough to generate PC5. So where did the waves come from? A scientist in Boulder whispered, "We can't find any source, except Atlas being exactly on the Sun-Earth line." No one answered, but the silence itself was an answer. Here is the scientific part. PC5 waves are the same kind of waves produced when Voyager crossed the heliopause, Cassini interacted with Saturn's magnetosphere, Parker Solar Probe dove near the Sun, New Horizons transitioned out of Earth's magnetotail. PC5 is like the breathing pattern of an object traveling through plasma. These waves are not sent deliberately. They are a consequence of physics. But Atlas stood out because PC5 usually requires a large object tens of meters wide, with a stable surface interacting with solar plasma. Atlas is a long cylindrical object, 200-300 m. A rotating cylinder can generate PC5 waves if its rotation is uniform, its structure is smooth, it interacts with the solar wind cyclically, and the PC5 frequency that day matched the inferred rotation period of Atlas before it went behind the sun perfectly. Not 1 second off. The scientific conclusion was unavoidable. Backhand index pointing right PC5 was Atlas's signature, not a message. Not intentional. Simply a physical footprint of a large, steadily rotating body in plasma. Every spacecraft, Voyager, Cassini, Parker, produces messy PC5 signals. Chaotic, noisy, irregular. Atlas's PC5 signal was clean as steady, consistent, unaffected by solar wind turbulence, unaltered by changes in plasma density. That level of stability made the room go silent. In physics, perfect stability usually indicates extreme symmetry, a very high moment of inertia, a structure shaped or worn in unusual ways. A plasma physicist in the UK finally said, "Not even our artificial satellites produce PC5 this clean. Nothing natural rotates that perfectly." And that sentence lingered in everyone's mind. Humans always expect signals like codes of beeps, flashing lights, or radio bursts, but the first message from Atlas was not something it transmitted, but something it maintained. Here is the core insight of Part 5. Even as the plasma environment shifted around it. In physics, this is extremely hard to achieve without some form of internal balance or inherent symmetry. Nature creates symmetry, but nature rarely keeps perfect stability inside chaotic plasma. The stability itself was the message. Not, "We are here," but, "We endure." A researcher in India cried quietly and said, "I don't think the first message was communication. I think it was a reminder that something out there persists in a way nature rarely allows." Atlas produced PC5 because it is long and cylindrical, it rotates uniformly, its surface interacts evenly with the solar wind, its plasma coupling is predictable, no evidence of intelligent signaling. No artificial modulation. Nothing that qualifies as a deliberate message. When you see an interstellar object rotating with perfect stability, unshaken by chaotic plasma, unmoved by solar wind variations, unchanged by magnetospheric turbulence, you feel something that doesn't fit into a research paper. You realize there is something out there more steady, more patient, more enduring than anything we have ever known. Something that travels through cold, empty space, holding its rotation like a heartbeat. And in that stability, humans heard something quiet, fragile, and real. You are not alone in the vast universe. Patterns are everywhere in the universe. In light, in gravity, in the slow drift of galaxies, in the way atoms arrange themselves to form life. But on October 5, 2025, humanity encountered a pattern that didn't belong anywhere in our textbooks. It was subtle, fragile, almost shy, and yet it shifted something in us, something deep and ancient, the part of the human mind that has always looked up at the night sky and wondered whether someone out there might one day look back. This is the story of that pattern, how we discovered it, how we misunderstood it, and how, in the quiet between the equations, it changed the way we see ourselves. 2 days after Atlas reappeared in Perseverance's images, something else entered the discussion. The cylinder in the Martian sky. At first, it looked like an imaging artifact, a stretched pixel, a cosmic ray hit on the camera sensor. Rovers capture anomalies like this all the time. But the problem was consistency. Across 6 images, taken over 19 minutes, the artifact moved. Not randomly, not like dust, not like camera noise, It traced a smooth arc, a trajectory too graceful to be mechanical failure, too steady to be wind-blown debris, and too elevated to be atmospheric. The cylinder was in Martian airspace, or above it. Scientists assumed it must be a satellite, maybe a fragment, maybe debris, something human-made that happened to pass between the rover and the faint morning sky. But Mars has only 8 active satellites. None of them were anywhere near Perseverance's line of sight that day. So what was it? A researcher at JPL whispered the thought everyone else was trying to avoid. It matches Atlas's reflectance profile. But the math disagreed. The altitude was wrong. The angle was wrong. The plasma environment was wrong. Atlas couldn't be there. And yet, something was. Something cylindrical. Something steady. Something that moved with purpose. 3 days later, data arrived from the Mars Climate Orbiter. A tiny variation in brightness. A rhythmic rise and fall over the course of an hour. Brightness curves tell us shape, rotation, surface texture, and reflectivity. They're like fingerprints for celestial objects. This light curve did not belong to dust, rock, or any natural body in the Martian sky. There were clues. A repeating modulation every 47 seconds, no scattering typical of irregular surfaces, a reflectance that matched polished metal, an energy dip synchronized with solar wind pressure. Natural surfaces don't do that. Natural surfaces scatter light chaotically, not in repeating patterns. But the most stunning feature was the phase resilience. Even when the solar wind surged, which should twist a rotating object off phase, the pattern stayed aligned, as if the object corrected itself in real time, as if it could feel its environment and adjust. The universe is full of surprises. But this was something else. Scientists argued. Models contradicted each other. Theories collapsed as quickly as they appeared. But the public saw the images long before the research papers were written. And ordinary people saw something scientists often forget to see. The emotion behind the mystery. People said, "It moves like it's alive. It feels aware. It's not chaotic. It's intentional. It's like it's listening." No one meant alive in the biological sense. They meant something deeper. The object moved with presence. Not the indifference of a rock drifting through vacuum. Not the erratic tumbling of debris. Presence. That feeling you get when something in the dark knows you're there. People don't always have the language of physics, but they have the language of instinct. And instinct was telling them something important. This pattern wasn't random. On October 9th, the European Space Agency released their first analysis. They found that the brightness variation wasn't just rotational. It contained substructure, tiny oscillations inside the larger 47-second cycle. Oscillations that formed a mathematical sequence. Not prime numbers, not Fibonacci, not anything cultural or symbolic, but something more fundamental. A naturally emerging solution to minimizing energy loss in rotating systems moving through variable plasma density. A pattern the universe produces only when something has a smooth surface, a uniform mass distribution, and extremely low structural imperfections. In other words, it wasn't signaling. It wasn't communicating. It was simply existing in a state of high optimization. As if its entire form, its shape, its mass, its rotation, had evolved or been crafted to move through space with the absolute minimum resistance. Like a fish moving through water without disturbing the surface. Like a whisper traveling through a quiet room without breaking the silence. A form built or eroded for endurance. The shock came when a team from Kyoto University reconstructed the full model. The object's rotation was stabilizing itself by interacting with solar wind pressure in a precise harmonic balance with the plasma environment of Mars. This phenomenon has a name: self-stabilizing plasma resonance. We have observed it only twice. In the tales of interstellar comets, and in a defunct, tumbling spacecraft that accidentally entered resonance before breaking apart, but the Martian cylinder didn't tumble. It didn't fragment. It didn't drift out of balance. It held resonance perfectly. Perfect resonance in a chaotic plasma environment is almost impossible. It means one thing, that act over millions, maybe billions of years. Not built in a workshop. Not launched by a civilization. Not engineered, formed, by time, by motion, by the rhythm of the universe itself. A relic of deep space, a survivor shaped by the same plasma fields that shape galaxies and stellar winds. A pattern written not by intelligence, but by eternity. And that was the moment scientists and ordinary people finally agreed on something. The pattern was not a message. It was a story of something old, something vast, something that has been drifting between stars long before humans learned to stand upright or look toward the sky. A story we were not ready for, because it forces us to confront our own fragility. Standing on a small planet in a small moment, facing something shaped by cosmic time. And in that realization came a quiet truth. Sometimes the universe teaches not with words, but with presence. And Atlas's presence whispered something that felt deeply, painfully human. You are young. You have so much left to learn. There are nights when the universe feels quiet, and nights when it feels like it is trying to speak. October 2025 became the second kind. Because for the first time in decades, 3 green comets appeared in our sky at once, each arriving from a different corner of the solar system, each carrying its own history, each glowing with the same uncanny color that has always captivated human imagination. Astronomers named them Lemon, Swan, and Atlas K-18. But the names hardly mattered. People didn't look up and see designations. They saw visitors, messengers, from places we still struggle to imagine. Comets turn green for a simple reason, but a reason that feels strangely poetic. Deep inside their icy nuclei lie carbon-rich molecules. When sunlight strikes them, it breaks those molecules apart, freeing a fragile pair of carbon atoms known as diatomic carbon. Diatomic carbon glows green only under intense ultraviolet light and only for a brief moment before it destroys itself. The green color is the light of something that exists just long enough to be beautiful, and then disappears. It is chemistry, but it feels like metaphor. And in October 2025, we saw that emerald glow 3 times over. Of the 3, Comet C/2025 A6 Lemon became the most captivating. When it was first discovered, it was so faint that astronomers mistook it for an asteroid. Predictions said it might reach magnitude 9, good for telescopes, invisible to the human eye. But comets do not care about our predictions. After emerging from the sun's glare in August, Lemon began to brighten, and then kept brightening. By late September, it reached magnitude 6. 6, borderline naked eye visibility. Its ion tail stretched 3 degrees across the sky, like a ghostly ribbon pulled taut by the solar wind. Astronomers updated their models again and again, trying to understand why it refused to behave like its orbit suggested. The consensus became this: Lemon wasn't just reflecting sunlight. It was releasing more gas than expected, meaning its surface was richer, younger, or more volatile than anyone had imagined. There are comets that perform as predicted. Lemon chose not to be one of them. Comet Swan arrived differently. It was discovered literally 1 day before perihelion, hidden for months in the sun's glare. The only reason we saw it at all was because NASA's SOHO spacecraft caught it in the corner of its field of view. By the time Earth-based telescopes picked it up, Swan was already moving away from the sun, its brightness fading, its structure expanding. Yet for a brief window in October, it glided near Mars, close enough that astrophotographers captured both worlds in the same frame. Swan didn't offer dramatic outbursts or long tails. its beauty was quieter. A small, sharp nucleus wrapped in a thin, pale green coma, like a candle in a glass sphere. Some objects in the sky shout. Swan whispered. The third comet, C/2025 K18 Atlas, was neither the brightest nor the most surprising. But it carried something the others didn't. Patience. It brightened slowly, steadily, following a path that required no updates, no revisions, no corrections. Its trajectory was clean, its evolution predictable, its green hue soft but steady. Astronomers loved Lemon for its spectacle, Swan for its subtlety, but Atlas K18 became a favorite for a different reason. In a year full of unexpected cosmic events, Atlas K18 was reliable. And reliability in both life and astronomy is a kind of beauty. Science never calls these events signs. The universe doesn't time its motions for human meaning, but humans do. And there is something undeniably striking about 3 emerald comets sweeping across our sky during a month already filled with anomalies, discoveries, and unanswered questions. For astronomers, it was a rare observational opportunity. For ordinary people, it was something else. A feeling. The feeling that the universe, usually so distant and indifferent, had turned its face toward us. Just for a moment, to remind us how small, how young, and how curious we still are. A comet is ancient ice surviving billions of years of silence. To see one is to look at something older than any mountain on Earth. To see 3 is to remember that the universe is allowed to surprise us, not just with danger, but with beauty. People talk about astronomy as if it's only data, numbers, orbital paths. But every discovery carries emotional weight. Wonder is a kind of gravity, pulls the mind upward. It stretches the imagination inward. It reminds us that even in a chaotic world, a world of layoffs, shutdowns, mysterious objects, and unanswered questions, there are still moments when the sky opens and something wordless enters the human heart. You don't need a telescope to understand that feeling. You only need to look up. By November, all 3 comets will fade from view. Their tails will thin, their comas dim, their nuclei drift into darkness. Lemon may not return for over 1,000 years, if it returns at all. Swan will disappear forever. Atlas K18 will slip back into the long arc of its orbit. They came, they glowed, they left, but they didn't leave us unchanged. Because for a few weeks in 2025, 3 pieces of the early solar system passed through our sky, not to warn, not to teach, not to communicate, but simply to exist. And sometimes existence alone is enough to move us. There are moments in human history when everything slows, when the noise of the world falls away, and all that remains is a single machine rising on a pillar of fire against the evening sky. October 13th, 2025 will be one of those moments. Because on that day, if weather, engineering, and luck all align, SpaceX will attempt the 11th test flight of Starship, the tallest, heaviest, and most powerful rocket humanity has ever built. But Flight 11 is not just another launch. It is the final mission of Starship version 2, the spacecraft that has failed, exploded, succeeded, and persevered more than any machine before it. This is the flight that decides everything. The future of Artemis, the future of human exploration, and whether the next generation of Starship version 3 will rise on a foundation of triumph or collapse under the weight of doubt. To understand why Flight 11 matters, we must understand the machine behind it, and the story that brought it to the edge of its most dangerous trial. 2025 has not been gentle. The year opened with a string of failures so severe that even supporters of the program felt the ground shift beneath their optimism. Just minutes after ascent, 4 Raptor engines shut down prematurely. The ship lost attitude control, data vanished, and the vehicle disintegrated over the Atlantic. Debris lit up the sky from Florida to the Caribbean. For a brief moment, it looked like redemption. The Super Heavy booster performed the first successful catch by the launch tower's giant mechanical arms. But joy lasted only 9 minutes. Ship 34 lost 4 engines, tumbled, and broke apart in upper atmosphere. The program's first reused booster flew, but the upper stage failed again. Another breakup, another investigation, another redesign. 3 failures in a row. 3 ships lost. 3 scars on SpaceX's ambition. For a machine meant to take humans to the moon, to Mars, and eventually beyond, both 2025 was the kind of year that could end a dream. But then Flight 10 happened. On August 10, 2025, after months of doubt, Starship version 2 finally did what it was meant to do. Climbed cleanly. Its engines held. Its guidance behaved. Its heat shield endured atmospheric re-entry. It landed gracefully, almost softly, in the Indian Ocean. And in the middle of its journey, it deployed Starlink simulator payloads, an essential test for future missions. It was the first time in 8 months that engineers at Starbase allowed themselves to breathe. Flight 10 wasn't perfect. A few tiles cracked. A heat plume appeared in a region that should have stayed cool. But it survived. And survival in rocketry is a kind of miracle. Flight 10 proved Starship could succeed. Flight 11 must prove that it can succeed on purpose. Flight 11 is not designed to be safe. It is designed to reveal weaknesses, to push Starship to the point where flaws become undeniable. Super Heavy Booster B-15 will ignite 13 engines at the start of its landing burn, highest ever for landing. Transition to 5 engines during its divert phase. Previously, this phase used 3. The new approach adds redundancy in case of spontaneous engine shutdown. End with a 3-engine hover above the Gulf of Mexico. If this works, SpaceX will have proven the landing technique that version 3 boosters will use. If it fails, the booster will hit the water at terminal velocity. Ship 38 will test 3 critical capabilities. 1. Raptor's relight in space, essential for lunar orbit insertions and Mars missions. Starlink payload deployment, using version 3 mechanisms needed for mass satellite launch. Heat shield stress test, engineers have intentionally removed tiles in areas with no underlying ablative shielding. If plasma penetrates those gaps, the ship may fail catastrophically. This is controlled danger, necessary danger, the kind of danger every future astronaut will silently thank these engineers for taking. Humanity has built thousands of rockets, but we have never built anything remotely like Starship. Its purpose is not simply to carry satellites or launch telescopes or send probes past Jupiter. Starship is meant to refuel itself in orbit, deliver 150 metric tons per launch, be fully reusable, carry human crews to the moon and land on Mars, enable surface habitats, form the backbone of interplanetary logistics, and create the first transportation system capable of sustaining a multi-planet civilization. Whether or not this dream succeeds depends on whether we can master supersonic belly flops, heat shield survival, orbital refueling, and engine relights in vacuum. Dreams on this scale require machinery that can do the impossible. And impossible machines require flights like Flight 11. NASA's Artemis 3 mission, scheduled for 2027, depends on Starship. If Starship cannot land reliably, cannot refuel in orbit, cannot withstand re-entry, or cannot demonstrate stability across multiple flights, then no astronaut will set foot on the moon in 2027, or 2028, or possibly even the early 2030s. NASA's own lander program has become entwined with SpaceX's success. And with China accelerating its lunar plans, a geopolitical race is unfolding quietly in the background of every Starship test. Flight 11 isn't happening in a vacuum. It's happening under pressure, not from physics, but from history. Starship must survive environments no spacecraft has ever endured. 1. Re-entry temperatures the heat shield faces. 1,450 degrees Celsius during Earth re-entry, potentially 1,700 degrees Celsius during lunar return, up to 2,000 degrees Celsius during Mars entry. The tiles are made of silica-based composites with extremely low thermal conductivity. But gaps between tiles remain the most dangerous failure mode. Plasma flow during re-entry. Ionized plasma forms a sheath around the ship, interfering with communications and stressing the structure unevenly. Small imperfections become large forces. Structural load Starship must endure. Aerodynamic buckling of vibrational harmonics, engine plume recirculation, supersonic roll, dynamic pressure spikes. Most spacecraft are designed for one of these. Starship must survive all of them. Raptor engine complexity. Raptor is the first full-flow staged combustion engine ever flown. It uses methane and oxygen, both supercooled, flowing through separate turbines at temperatures above 3,000 degrees Celsius in combustion. With pressures of 330 bar, it is the most efficient engine ever built and one of the most temperamental. Flight 11 will push Raptor harder than any flight before it. People think rockets fail because of engineering flaws. Sometimes they fail because of pressure. Political pressure, financial pressure, public expectation, fear of losing ground to other nations, the weight of a dream that feels too large to hold. The hardest pressures, though, are internal. Ask any engineer who has watched their work explode. They will tell you, the failure is not the fireball. The failure is the silence after, the moment when doubt enters the room. Flight 11 is not just a test of steel and engines. It is a test of human resilience. Not resilience in the abstract, but the resilience of thousands of people who have devoted years of their lives to something the world may never fully understand. On October 13th, as the countdown reaches 0, all the noise of the world will condense into a single moment. 33 Raptor engines igniting at once, creating the most powerful thrust ever generated by a human-made machine. For a few seconds, the Earth will tremble. People hundreds of miles away will feel the vibrations. And somewhere inside every person watching, whether on a beach, in a control room, or through a glowing screen in the dark, something ancient will stir. The part of us that remembers why we look up. If Flight 11 succeeds, it will open the door to Version 3 boosters, a Version 3 ships, orbital refueling tests, the first lunar lander prototypes, and the first cargo deliveries to Mars, and the architecture needed to build a multi-planet civilization. If it fails, it will not be the end. But it will slow everything by months, maybe by years. And time is something the universe never gives back. Starship is not important because of Mars, or the Moon, or even exploration. Starship is important because it reminds us that humanity still dares to attempt things that might break us. We are a species that builds impossible machines knowing they may explode, because the alternative is to stop reaching. And when we stop reaching, we stop being human. Flight 11 is not a test of hardware. It is a test of spirit. A test of whether our species is still brave enough to step into the unknown and whisper into the void. We are still here. We are still trying. We still believe. While the United States debates budgets, reorganizes teams, and pins its hopes on Starship's next test flight, another nation is moving with quiet, deliberate precision. A nation that rarely announces bold promises, but almost always delivers steady results. In 2025, that nation is China, and its mission Tianwen-2 may reshape everything we thought we knew about the Moon, about Earth's orbital neighborhood, and about who leads humanity's next great era of exploration. On May 28, 2025 at 1:31 a.m. local time, a Long March 3B rocket lifted off from Xichang Satellite Launch Center. Few people outside the space community noticed, but what that rocket carried was historic. Tianwen-2, China's first near-Earth asteroid sample return mission. Its target is not a famous comet or a high-profile asteroid. It is something far stranger. 2016 HO3, Kamoʻoalewa, Earth's closest, most stable quasi-satellite. A small object that dances around Earth while orbiting the Sun. A silent companion we did not know existed until 2016. And the mystery is this. Its spectral signature looks like lunar rock, weathered, ancient, possibly ejected from the moon long ago. If true, it would mean a piece of the moon broke off a survived ejection, settled into a stable, Earth-like orbit, and has been circling with us for centuries or millennia. No mission in history has attempted to sample a quasi-satellite, or resolve the question of whether it is a fossil fragment of the moon. Tianwen-2 is the first. Kamoʻoalewa is small, just 40 to 100 meters across. It rotates once every 28 minutes, making it one of the fastest rotators ever targeted. Its orbit is peculiar. It never drifts far from Earth. It mimics Earth's year. It appears to circle us. Though it technically doesn't, it stays gravitationally in step with our planet. Asteroids rarely behave like this. The spectral evidence deepens the mystery. It reflects light like lunar regolith. It contains silicate patterns resembling weathered basalt. It lacks the metal-rich signatures of typical asteroids. Its albedo resembles fragments from known lunar craters. There are two possible explanations. Theory 1. A lunar fragment, a massive ancient impact struck the moon and flung debris into solar orbit. One piece survived, stabilized, and now follows Earth. Theory 2. A migrated main-belt asteroid. It may have drifted inward over millions of years. Its lunar-like spectrum could be due to space weathering. Either answer would rewrite models of asteroid migration, impact physics, and the history of Earth-Moon interactions. This is why Tianwen-2 matters. Tianwen-2 is one of the most complex robotic missions ever attempted. It will 1. Travel over 3 million kilometers from Earth. 2. Match velocity with a tiny, fast-spinning asteroid. 3. Orbit a body smaller than a football stadium. 4. Collect samples using 3 techniques. O hover sampling, O touch and go, like OSIRIS-RX. O anchored drilling using robotic legs. 5. Return those samples to Earth in 2028. 6. Then use Earth's gravity to slingshot to a comet. 311P/Pan-STARRS. 7. Study a main belt comet for years. 1 spacecraft. 2 targets. A decade-long mission. Dozens of scientific firsts. This is the kind of mission NASA used to build. Now China is building it. If Tianwen-2 returns samples first and proves they are lunar fragments, China will achieve something the U.S. has not done. Confirm a natural lunar sample from outside the moon, rewrite Earth-Moon impact history, demonstrate deep space sample return capability, establish leadership in near-Earth asteroid operations. But it connects to something larger. China's long-term moon strategy. China is building a permanent lunar base with Russia, developing heavy-lift rockets, Long March 10th, completing the Kaoʻaalewa communications relay system, advancing reusable spacecraft, preparing lunar sample return missions, Chang'e 6 to 8, planning human landings in the early 2030s, exploring nuclear reactors for lunar power while NASA experiences layoffs, shutdowns, and uncertain budgets. China's program is stable, funded, and moving step by step. This is why U.S. lawmakers warn, the next footprints on the moon might not be American. Tianwen-2 is not just a scientific mission. It is a flag planted in deep space, quietly, methodically, confidently. Space isn't only about engineering or geopolitics. It's about emotion, the quiet feeling that we are part of something bigger. For years, many people thought of China's program as distant, robotic, technical, cold. But Tianwen-2 changes that, because its target is not a distant comet or a world no one can imagine. It is something that circles with us, a silent companion in our orbital path. A tiny world that has been near Earth long before any of us opened our eyes. There is something deeply human about reaching out to touch a companion we didn't know we had, to lift a piece of the cosmos that has been drifting beside us for centuries. It reminds us of something important. Humans explore not just to compete, but to understand where we came from, and what else has been journeying with us through the dark. Tianwen-2 may determine how Earth and the Moon formed, how asteroid fragments migrate, how impacts shaped early life, whether Earth has natural co-orbiting debris, whether humans can reliably sample objects smaller than skyscrapers, who leads the next era of deep space exploration. But beyond that, it matters because it is proof that curiosity still wins. Even in a world full of noise, pressure, and division, there are still nations willing to spend years and billions chasing a rock smaller than a city block because of the questions it might answer. This is what defines a civilization, what we choose to pursue when no one is forcing us to pursue it. While the U.S. refines Starship, while NASA fights for funding, while the world debates politics, Tianwen-2 is already on its long arc toward a small, mysterious world that has been dancing beside Earth in patient silence. A mission many ignored at launch may become the mission everyone remembers when the samples return. Because if those grains of dust prove to be lunar in origin, if a piece of our moon has been orbiting with us like a forgotten sibling, then the story of Earth changes. Not loudly, not dramatically, but quietly, in a way only the universe can whisper. For decades, NASA felt like the steady heartbeat of exploration. A pulse that never stopped, no matter who was president, no matter how turbulent the world became. But in October 2025, for the first time in its modern history, that heartbeat faltered. What unfolded was not a single crisis, but the collision of many. Budget collapse, political pressure, workforce loss, and the slow unraveling of programs that once defined America's leadership in space. This is not a story about rockets or robots. It is a story about what happens when a nation forgets that exploration requires continuity, stability, and the courage to think in decades, not election cycles. And now, NASA stands at a crossroads more fragile than most people realize. At 12:01 a.m. on October 1, 2025, the United States federal government shut down. Within hours, 15,000 NASA employees were furloughed. Buildings went dark. Research halted. Labs froze mid-experiment. Only 2 categories of workers were allowed to remain. 1. ISS operations team, roughly 3,000 employees who keep astronauts alive aboard the International Space Station. They continued working without pay, sending over 1,000 commands a day, monitoring oxygen, CO2 scrubbers, coolant loops, and emergency systems. Artemis program workers, because NASA leadership declared, China is not going to the moon with good intentions. The implication was clear. The moon had become a national security priority. So thousands of contractors at SpaceX, Blue Origin, Lockheed Martin, and NASA centers were ordered to keep working, even though the agency technically had no budget. This was the first sign of fracture. Exploration driven not by vision, but by fear. The shutdown was only the surface of the problem. For months leading up to October, NASA leadership had quietly issued directives ordering the reduction of over 4,000 employees between September 2025 and January 2026. These were not furloughs. These were permanent departures. The people leaving included senior propulsion engineers, nuclear power specialists, deep space navigation experts, planetary scientists of veterans who had worked on ISS, Orion, JWST, and Mars missions, the leading expert for lunar nuclear surface reactors at Johnson Space Center, the kind of knowledge you cannot hire back with a job posting. Knowledge that takes decades to cultivate. A NASA engineer described it bluntly. We aren't losing workers. We're losing memory. When memory dies in a space agency, programs die quietly with it. President Trump's proposed budget for FY 2026, released in early 2025, hit NASA harder than any proposal in the last half-century. Adjusted for inflation, it would give NASA the lowest funding since 1961. And worse, crossmark a 47% cut to NASA's Science Division, crossmark 41 missions scheduled for cancellation, crossmark including missions already in flight. These included Nancy Grace Roman Space Telescope, almost fully built, designed to find exoplanets and dark energy signatures. OSIRIS Apex, en route to study asteroid Apophis, could be shut down mid-flight. Chandra X-ray Observatory, active since 1999, one of the greatest astrophysics instruments ever flown. Hubble Space Telescope mission support, reduced to the point of risking deactivation. Earth science satellites tracking climate change, sea levels, and deforestation. Planetary defense programs. Ironically, right after asteroid 2025 TF slipped past Earth undetected, NASA scientists rarely speak publicly against policy, but this time, many did. Because this wasn't budget trimming. This was a strategic amputation. Nothing illustrates NASA's vulnerability more than the Mars Sample Return Program. The Perseverance rover has already sealed samples that may contain evidence of ancient life on Mars. Those samples are sitting on the Martian surface, waiting. But MSR has ballooned in cost, fallen behind schedule, been targeted for cancellation, lost hundreds of engineers in the workforce cuts, been overshadowed by China's rising program. During the September 2025 press conference, NASA leadership quietly admitted, "We may need to abandon the original MSR architecture and find a cheaper alternative." Meanwhile, China announced it could launch its own Mars sample return as early as 2028. If NASA abandons MSR and China brings back Martian samples first, it would become one of the most symbolic turning points in the history of planetary science. Not because of national pride, but because it would mark the moment the United States ceded leadership in deep space exploration. NASA does not operate alone. It partners with ESA, Europe, EJAXA, Japan, ICSA, Canada, CNSA, China, historically not. Universities to private industry when NASA halts funding, cancels missions, or restructures programs. International missions collapse with it. Decades-long collaborations suddenly lose their anchor. ESA officials have already raised concerns that American volatility is harming missions like Mars Sample Return, Euclid follow-ons, Artemis surface habitat studies, Lunar Gateway logistics. Attempts to repair trust take years. Losing trust can take days. People imagine NASA as machines and budgets. But NASA is made of people. Engineers who stay up 36 hours during a critical maneuver, scientists who dedicate 20 years to one mission, flight controllers who whisper, "Come on," during re-entry, interns who dream of the first humans stepping onto Mars, families who move every few years to follow the program. Space exploration is a human act. And humans need stability. When they lose it, exploration falters. NASA won't collapse overnight, but it can drift. Slowly, silently, invisibly. The signs of drift are subtle. Programs delayed by a year, then 2, then indefinitely. Missions launched with reduced capabilities, fewer graduate students entering space science, aging spacecraft not replaced, a new technology left untested, gaps in planetary defense, reduced leadership in lunar operations, delayed Mars architecture, loss of public excitement, reliance on foreign launchers or data. Space exploration has inertia. It keeps going long after the damage begins. By the time the effects are visible, years of ground have already been lost. Despite everything, there is something extraordinary that remains alive inside NASA. A culture that refuses to give up. Engineers still show up, even unpaid. Scientists continue analyzing data on their own time. Centers collaborate in the background. Graduate students keep proposing new instruments. Astronauts train for missions that don't yet have dates. Even when budgets collapse, hope does not. Because the story of NASA has never been linear. It has always been a cycle of struggle and resurgence. After Apollo ended, NASA nearly collapsed. After Challenger, many doubted the shuttle. After Columbia, NASA reinvented human spaceflight. After Constellation was canceled, Artemis was born. NASA's greatest strength is not money. It is resilience. But resilience needs time. It needs consistency. It needs leaders willing to protect long-term vision over short-term politics. Without that, even resilience can break. Thunderstorm crescent moon in the quiet of 2025. NASA stands in a moment that will define its next decade. A shrinking workforce or a slashed budget, a shutdown, 41 missions on the chopping block, international partners watching closely, China rising quickly, a Artemis depending on Starship, a world losing faith in long-term exploration, but history shows something important. NASA's lowest moments have often preceded its greatest achievements. And somewhere, right now, in dark labs and quiet mission control rooms, people are still fighting for that future. Quietly, steadily, stubbornly. Because the universe will not stop moving, and exploration will not wait forever. Humanity must decide whether it will keep reaching for the worlds above us, or let them drift away. There are moments when humanity imagines that it has all the time in the world. Time to plan, time to argue, time to postpone decisions until politics settle or budgets recover or uncertainty fades. But the universe does not pause for human hesitation. It keeps unfolding, quietly, relentlessly, with or without us. And October 2025 made that truth impossible to ignore. In a single month, an asteroid slipped past Earth undetected, a possible biosignature appeared on Mars, a strange cylinder crossed the Martian sky, 3 green comets ignited our atmosphere. The Sun entered its last gasp phase. China launched a mission that may rewrite lunar history. NASA fell into crisis. A Starship faced the test that could shape the next decade's 7 events. 7 reminders. The universe continues its ancient choreography whether we watch or not. It does not wait for budgets or elections or geopolitical alignment. Every day we hesitate is a day the universe moves forward without us. Atlas, the interstellar visitor, is the clearest symbol of this truth. A tiny object from a place we cannot even map, passing through our solar system for reasons we barely understand. It does not slow down for our arguments or uncertainties. It does not alter its trajectory to accommodate our schedules. It will drift past the Sun, cross the heliopause, and return to interstellar darkness long before we finish debating how much exploration is worth. Objects like Atlas carry no malice. But they carry truth. We are not the center of anything, and we are not guaranteed a second chance to learn. On Mars, Perseverance sits silently, its sealed tubes holding samples that may contain the first true evidence of life beyond Earth. Those samples do not degrade quickly, but they are not eternal. Dust storms may bury them. Hardware may weaken. Electronics may fail. Mars sample return may be delayed past the point of recovery. Mars is patient. Geology always is. But patience is not the same as permanence. If humanity waits too long, the opportunity will vanish quietly. Not in an explosion or catastrophe, but in the slow erosion of neglected ambition. The Sun's magnetic cycle does not care about shutdowns or funding disputes. Solar maximum brings stronger solar winds, more CMEs, disruptions to power grids, GPS irregularities, satellite drag, atmospheric expansion. These are predictable, measurable, and scientifically understood. But our readiness is not. The Sun will continue its 11-year rhythm. Our infrastructure either adapts or breaks, and the universe will not pause while we decide which outcome we prefer. While the U.S. navigates internal turmoil, China has done what the universe itself does: move forward. Quietly, steadily, relentlessly. Tianwen-2 on its way to Kamoʻoalewa, Chang'e 6 returning samples, lunar base planning, heavy lift rockets in development, nuclear-powered lunar systems, human landing plans for the early 2030s. China is not rushing. It is progressing step by step, year by year. The universe rewards momentum, not declarations. Civilizations do not die from disaster alone. Sometimes they die from apathy. The greatest filter may not be asteroids or gamma-ray bursts or rogue stars. It may be the moment when a civilization stops looking up, stops funding knowledge, stops dreaming, stops daring to take risks because the cost seems too high and the payoff is too distant. The universe doesn't punish such civilizations. It simply moves on without them. For every budget cut, an engineer is working late without being asked. For every canceled program, there is a researcher still analyzing data long after funding ends. For every mission delayed, students are building the next generation of instruments in small labs with borrowed equipment. For every spacecraft failing in silence, there is another launching on a column of fire. Humanity is not done. We are not exhausted. We are distracted but not defeated. The universe keeps moving, but so do we. Humanity now stands at a decision point as significant as any in its history. We can let exploration drift into the background, postpone decisions until opportunities fade, or watch other nations take the lead, or wait until the sky grows quiet again, or we can choose differently. We can choose to invest, to rebuild, to collaborate, to confront uncertainty with curiosity instead of fear. We can choose to do what our ancestors did when they first crossed oceans, mapped continents, built telescopes, and wondered what lay beyond the stars. We can choose to keep going. Every comet that passes, every asteroid that brushes by, every solar storm, every strange object in the Martian sky, each one is an invitation. Not a warning, not a threat, an invitation to learn, to reach, to remember who we are. Because the universe is not hostile. It is simply indifferent. And indifference leaves room for those brave enough to step forward. The universe doesn't wait, but it does welcome those who choose to meet it halfway. As October 2025 draws to a close, after comets, crises, rockets, shutdowns, flashes in the Martian night, and storms on the solar wind, humanity is left with a single truth. The universe owes us nothing, but it offers us everything. If we choose to take it, if we choose to continue, if we choose not to wait, the universe does not raise its voice. It does not shout its warnings or sing its invitations. It speaks in the faintest ways. A pale streak in a Martian photograph, a whisper of plasma around a returning ship, a silent companion asteroid circling Earth, a storm brewing on the surface of our sun tonight. You have traveled through all of them. Through Atlas drifting across the solar system like a messenger without a language. Through forgotten comets that glow emerald against the darkness of interplanetary night. Through the spacecraft's struggles, agencies collapsing, dreams trembling on the edge of flame. And yet beneath every crisis, every unanswered question, every fragment of mystery, there is something else creeping: possibility. History rarely announces the start of a new era. It looks like confusion, like broken rockets, like arguments over budgets, like scientists working without sleep, like engineers refusing to abandon their stations. But that is how beginnings always look. Before Apollo, there were failures. Before Hubble, there were doubts. Before every great discovery, there was a long, uncomfortable silence that felt like the end, yet was really the threshold. 2025 is one of those thresholds. The year when interstellar visitors passed through our sky. When China touched a hidden companion of the Earth. When NASA fell into crisis but kept breathing anyway. When Starship prepared the test that could reshape the next decade. When the sun reminded us how fragile our world can be. This is not a collapse. It is a transition. The old version of exploration is fading. A new one is waiting to be born. Despite everything, the shutdowns, the layoffs, the political storms, the tensions, the failures, the debris, the universe remains unchanged. It is still out there, quiet, ancient, patient, stretching in every direction, filled with worlds that have never felt human eyes. There are oceans under frozen moons. There are glaciers made of methane. There are planets covered in diamond storms. There are comets older than the Earth carrying secrets from the dawn of time. And somewhere beyond all of it, beyond the heliopause, beyond the cold winds of interstellar space, Atlas is still moving, still glowing faintly as its ices sublimate, still carrying whatever story it brought with it. One day, humanity will follow, if we choose to. Every advance we have made, from the first telescope to the first lunar footprint, came from people who were willing to carry a dream far longer than comfort allowed. We stand on their shoulders. And now, the next step belongs to us. To finish what perseverance began. To return samples from Mars. To follow Kamoʻoalewa's strange orbit and learn whether it holds a piece of our own moon. To protect Earth from the objects we have only recently learned to detect. To build Starship version 3 and open the road between worlds. To bring humanity back to the moon, not for flags or competition, but for knowledge, for permanence, for the birth of something larger than any nation. These are not distant dreams. They are invitations waiting for a generation brave enough to say yes. As this journey comes to a close, let your breath slow. Let your mind drift. Imagine the world not as it is, but as it could be. A moon base glowing under weak sunlight. A starship lifting off in silence from the red dust of Mars. An astronaut is placing their hand on a rock returned from an interstellar visitor. A comet breaking open to reveal organic molecules older than Earth. Children looking up at the night sky, not with fear, but with recognition. As if they understand that those stars are the next pages of a book we have only begun to write. Because they are. Because we are. As the night closes around you and the last echoes of this story fade, remember something simple and quietly powerful. The universe doesn't wait, but it also doesn't close the door. It will still be here tomorrow, and the day after, and long after that, holding mysteries, whispers, and possibilities for anyone willing to listen. And if you ever feel small under the vastness of the stars, remember, you are made of them. You are part of them. You carry their history in every atom of your being. The universe is not separate from you. It is the oldest part of who you are. And it is still inviting you to continue the journey. Solar storms are not born in silence. They rise from tension, from magnetic knots twisted so tightly that even a star can no longer hold its breath. And in the quiet dawn of October 2025, astronomers across the world realized something profound. Our sun has entered its last gasp. Not a death, not an ending, but a final surge of strength. A radiant crescendo in its 11-year cycle that will paint the skies of Earth in colors we haven't seen in decades. Tonight, let your breathing slow, and let me carry you through the story of the star that raised us, and the fire is exhaling now. A star in tension. Most people imagine the sun as a simple ball of burning fire. But stars are not flames. They are fields, endless oceans of magnetism twisting, tightening, collapsing, erupting. During solar maximum, the sun's magnetic field becomes unstable, as if the entire star is clenching its fists after a decade of quiet breathing. Sunspots bloom like dark bruises. Magnetic arcs snap open, releasing flares brighter than 1 billion nuclear bombs. And sometimes, the sun coughs out a coronal mass ejection, a cloud of plasma heavier than mountains, racing through space at 1,000,000 miles per hour. But solar maximum is not the climax. Not yet. The most dramatic auroras come after the peak. Because when the frenzy fades, something deeper emerges. Something more continuous, more persistent, more able to shake the magnetic shield that protects Earth. Coronal holes, the sun's open wounds as solar activity begins its slow decline. The sun develops coronal holes, dark regions where magnetic fields open outward like portals into space. Through these openings, streams of charged particles escape at speeds approaching 800 kilometers per second. Unlike the violent bursts of a flare, coronal holes are steady. They can last for days, sometimes weeks, hammering Earth's magnetic field again and again like a steady cosmic heartbeat. And this is why auroras intensify after maximum. A flare is a lightning strike. A coronal hole is a storm front. The first surprises you, the second lingers. Earth's magnetic dance when solar wind meets Earth. Our planet doesn't simply absorb it. It bends, twists, reacts. Earth's magnetic field stretches like a shimmering veil, a shield forged by our planet's rotating iron core. When the solar wind grows strong enough, the shield cracks open near the poles and funnels charged particles downward. What follows is not fire, not sparks, but light. Particles collide with oxygen atoms 120 kilometers above Earth, and the sky glows green. Collide with nitrogen, and the horizon turns purple, pink, or blue. During strong storms, the auroras migrate southward, rolling across the sky like curtains of breathing light. And now, in 2025, that migration is beginning again. The same cycle that once inspired ancient myths of gods dancing in the sky. The physics of wonder, the KP index, a 0 to 9 scale of geomagnetic disturbance, hovered between 4 and 5 in early October, with bursts into storm territory. Even quiet nights in Iceland, Norway, and Canada were suddenly flooded with color. Long exposure cameras captured walls of emerald, ribbons of violet, and rivers of pale blue stretching across the heavens. Aurora forecasters warn that the next 2 years, 2025 to 2027, could become the brightest auroral period in an entire generation. And yet, that beauty carries a shadow. Storms that can touch the ground. In March 1989, a single CME caused Quebec's power grid to collapse. Transformers melted. Millions were plunged into darkness for 9 hours. That storm reached G5, the highest classification. What we see now in 2025 rests mostly at G1 or G2, gentle by comparison. But coronal holes can surprise. And if a perfect storm were to hit Earth, directed, compressed, aligned just right, it could damage satellites, disrupt GPS, silence radio networks, and degrade the power grids that keep cities alive. The sun does not aim. It simply breathes. We happen to live close enough to feel the warmth of its exhale. Why the sun's last gasp matters now? It matters because our world is increasingly technological and increasingly fragile. It matters because every aurora is a message from the star that made our oceans, our trees, our bodies, our breath. It matters because the cycles of the sun teach us humility, reminding us that even in its quiet moments, our star remains powerful beyond measure. But above all, it matters because these lights in the sky remind us how small, how tender, how miraculous Earth truly is. A green whisper above the Arctic is not just chemistry. It is a reminder that we orbit a living star. A reminder that even storms have beauty. A reminder that the universe never stops moving, never stops speaking, never stops shining. Science doesn't collapse all at once. It unravels silently, first in budgets, then in hallways, then in the hearts of the people who keep the lights on in our collective imagination. October 1st, 2025, it was the day the unraveling became visible. At 12:01 a.m., the United States government shut down. Within hours, 15,000 NASA employees received furlough notices. Not pink slips, not protests, just quiet. Offices are closing their doors. Research labs are falling dark. Simulations frozen mid-calculation. Projects paused in the middle of decades-long arcs. Most of NASA went home, but just a few stayed behind. They worked without pay to keep spacecraft alive millions of kilometers away. People forget this. Spacecraft need constant care. They are not statues drifting in the dark. They are fragile machines walking tightropes of physics. Without the quiet hands of ground controllers, oxygen levels drift, telemetry freezes, radiation spikes unnoticed. A shutdown on Earth echoes all the way to low Earth orbit. The only program allowed to keep moving was Artemis. Not for science, not for exploration, but for geopolitics. The acting NASA administrator said it openly. China is not going to the moon with good intentions. So the moon became an emergency, priority, a justification for leaving thousands unpaid so that a handful could continue building the spacecraft meant to carry humans back to the lunar surface. It is a strange thing to see exploration held up not as a dream, but as a defense. Months before the shutdown, NASA began losing people. Engineers with decades of experience, propulsion experts, power system architects, planetary scientists, astrophysicists, flight controllers. More than 4,000 permanent departures were scheduled between September 2025 and January 2026. Not furloughs, not temporary departures. A fifth of NASA's workforce gone. Some walked away voluntarily. Others were pushed by budget uncertainty. Others simply realized that the dream they once served was no longer being protected. You can rebuild hardware, but there is no machine to rebuild expertise. The proposed 2026 budget cut NASA science funding by 47%, the lowest, adjusted for inflation, since 1961. Placed 41 missions in danger, some still on the launch pad, some already in deep space, some collecting irreplaceable data from worlds we may never visit again. Among them, Chandra X-ray Observatory, a Hubble Space Telescope, OSIRIS-APEX, Earth climate satellites, planetary defense programs, Mars sample return. Imagine turning off Hubble, the telescope that revealed our place in the universe, not because it failed, but because of paperwork. Imagine abandoning Mars samples already sealed in titanium tubes, waiting on the red dust for a return mission that may never come. Science fades not with explosions, but with budget lines. NASA's collapse does not stay within NASA. It spreads. Universities rely on NASA grants to pay graduate students, postdocs, instrument builders, mission analysts. When grants pause, careers end. Projekts die. Entire scientific fields shrink. One astrophysicist said, "It's not just the launch being delayed, it's an entire generation losing its future." NASA is not alone in its missions. It has partners: Europe, Japan, Canada, Australia. When NASA wavers, alliance structures tremble. The European Space Agency, expecting NASA to retrieve the Mars samples, now whispers about contingency plans. Because science once shared cannot be unshared. Trust is a currency, and right now it is leaking. NASA has always lived on a knife edge between politics and possibility, between Congress and cosmos, between budgets and the boundless. But 2025 feels different, because this time the danger isn't external. It is internal. Decision by decision, cut by cut, delay by delay. NASA risks becoming a museum of its past instead of a steward of our future. And that future is fragile. If NASA dims, the world doesn't just lose missions. it loses momentum, it loses vision, it loses the compass that once pointed humanity toward the stars. The universe has no patience. It expands whether we study it or not. It evolves whether we are ready or not. It writes stories in starlight that continue even when we stop paying attention. Asteroids do not pause because our budgets are delayed. Solar storms do not weaken because our institutions crumble. Life on Mars does not wait for human politics to settle. The cosmos moves with or without us. But the question tonight is not whether the universe continues. The question is, do we? Do we continue looking up? Do we continue reaching? Do we continue choosing curiosity over fear, wonder over apathy, exploration over stagnation? Humanity's greatest danger is not the asteroid we don't see, the solar storm we don't expect, the UFO we can't explain, or the comet glowing green in the dark. Our greatest danger is forgetting to care, forgetting to listen, forgetting to wonder, forgetting that we are made from the dust of ancient stars, and those stars still call to us even now. The universe doesn't wait, but it does invite, every night, in every direction, with every photon that has traveled billions of years just to touch your eyes for a single heartbeat. The cosmos waits for no one, but it whispers to everyone. So as this journey comes to an end, let your breath soften, let your shoulders fall, let the weight of everything you cannot control drift away like dust in the solar wind. Tonight, you have traveled from Mars to the Sun to the edge of NASA's future and back again. And through it all, one truth remains. You are part of this universe, and it is part of you. The atoms in your blood were born in stars older than Earth. The iron in your heart once glowed in the core of a supernova. The light touching your skin right now began its journey before humanity learned to speak. So rest, breathe, feel the quiet gravity of existence wrap around you like a cosmic blanket. And when you look up tomorrow, even for a moment, remember, the universe is not far away. It has been inside you all along. Good night, traveler. May the stars keep you. May the darkness soothe you. And may tomorrow find you lighter than today.